Welcome back to another video of Linux Hardening series. In this video, I'm configuring the Uncomplicated Firewall, also known as UFW. A firewall is one of the first layers of defense for any Linux server. It controls which network connections are allowed and blocks unwanted traffic. In cloud security, every exposed port increases the attack surface, so the principle is to allow only the services that are absolutely necessary. Before enabling the firewall, I must allow SSH access to avoid locking myself out of the server. First, I'll verify whether UFW is already installed by executing sudo UFW version. Ubuntu server usually includes it by default, but verifying before configuring is always a good practice. Enterprise engineers never assume software is installed. They verify the environment before making security changes. If it is not installed, install it by executing sudo apt update and then sudo apt install UFW-y. Before making any changes, I'm checking the current firewall status by sudo UFW status verbose. This helps me understand whether the firewall is already active and whether any existing rules could affect my configuration. Always inspect the current state before modifying security controls. Before enabling the firewall, I'm explicitly allowing SSH traffic. Since I'm connected remotely, blocking SSH would immediately disconnect my session and require console access to recover. This is one of the most common mistakes beginners make, so allowing SSH first is considered a mandatory best practice. To allow SSH, enter sudo UFW allow open SSH or sudo UFW allow 22/TCP. Verify the rule, sudo UFW status. Now that SSH is allowed, I can safely enable the firewall. From this point onward, any incoming connection that doesn't match an allowed rule will be blocked automatically. This follows the default deny security principle used across enterprise cloud environments. To enable firewall, we execute sudo UFW enable. Now, the firewall is active and enabled on system startup. After enabling the firewall, I always verify the configuration by entering sudo UFW status verbose. Verification confirms that the firewall is active, the correct rules are applied, and SSH remains accessible. Security engineers never assume configurations worked. They always validate the final state. Besides checking firewall rules, I also verify that the firewall service is running correctly using sudo systemctl status UFW. This confirms that UFW started successfully and will continue protecting the server after a reboot. Enterprise security controls must survive system restarts. To confirm that the firewall remains enabled after reboot, I'll verify its status after restarting the server. Persistence is essential for maintaining continuous protection. Now, let's restart the server. Reconnect using SSH, then verify. Sudo UFW status verbose. Now, we have successfully installed and configured the Ubuntu Firewall using UFW. We verified its availability, checked its current status, allowed SSH access, enabled the firewall, validated the applied rules, confirmed the firewall service was running, and ensured the configuration persists after a reboot. We configured the firewall to reduce the server's attack surface by allowing only authorized network traffic. This implements the principle of least privilege at the network layer, protects the server from unauthorized access attempts, and provides a foundational security control that every production Linux server should have before hosting applications or cloud services. In the next video, we'll strengthen our server security even further by installing fail2ban and exploring Linux audit logs. We'll configure fail2ban to automatically detect and block repeated login attempts, helping defend against brute force attacks. Then, we'll learn how to read authentication and system logs to monitor user activity, investigate security events, and troubleshoot issues. These are essential skills used by cloud security engineers and DevSecOps teams to protect and monitor production Linux servers.